Hello there. In the last episode of this side quest, we designed and 3D printed this magnetic fidget slider, which is currently available completely for free on my things.com profile. In this episode, I want to use some of the things we learned in the last episode to make a new 3D printable fidget toy, a fidget dial that spins and uses magnets to index the rotation. So let's make it. Okay, so my goal in this episode is to design a 3D printable fidget dial that incorporates magnets to index its rotation, similar to how the magnets index the sliding motion of the fidget slider. My target is to make the rotation feel snappy, but I also want it to be loose enough that it'll spin freely for a second if you give it enough force. I want to be able to hold the sides of the dial and just spin a thin ridge on the outer edge, so it's going to have to be printed as a few separate pieces that get assembled together, which I want to be able to do without any kind of glue or other fasteners, just the 3D printed parts and the magnets. If you want to try printing it out yourself, you can get the model for free on my things.com profile. The link to it's down in the description. I've also included a link to the exact magnets that I used, which are the same ones that we used in the fidget slider, so you can buy just one package of magnets to use for all of the models. I also have affiliate links in the description for the material that I used, as well as all of the 3D printing hardware that I use, in case you want to try any of it out for yourself and help support the channel in the process. Now let's start working on this thing in Fusion 360. Alright, so I know that I'm going to be patterning almost all of the features in this model, so I'm going to try my best to sketch and model each feature one at a time, rather than doing one big sketch at the beginning like I've done in previous episodes. I'm also going to utilize parametric parameters as much as possible so that I can easily make adjustments by simply updating the parameters rather than needing to edit the actual features. Since I already know that the magnet slots in the fidget slider work really well, I'm going to use the exact same geometry for the magnet slots in this model as well. If it ain't broke, don't fix it. I want the center rotating disc to be free floating between the top and the bottom caps, so I know that I'm going to need to print all three of those as separate pieces. I'll then make a post which the middle disc will fit over that connects the two caps together. Lastly, I want to have an outer ring that just press fits over the center disc and that has the knurl ridges around it to give it better grip. I started out by modeling the center disc since that'll be the basis for the caps as well. Again, I used the parameters as much as possible and copied the magnet slot geometry directly from the fidget slider. Instead of patterning the magnet slots in the base sketch, I modeled one slot completely and then patterned the features that made it around the disc. I then moved on to making the caps, starting by duplicating the center disc. Once I had the duplicate positioned where I wanted it, I created the cap by sketching the profile that I wanted and then just revolving it around the center of the disc. This was probably the most organic and by feel section of the design process for this model. I just kind of created shapes and sizes that seemed good and tweaked them until they felt just right. Next, I modeled what was probably the most complicated part of this design, the center post. The idea behind it is pretty straightforward, but getting everything to line up properly and lock together securely was really difficult and took multiple revisions. Basically, the center post has 3 tabs sticking out on each end, which were patterned from a single tab. These 3 tabs fit into 3 slots in the caps, which were also patterned from a single slot. The caps can then be rotated to lock the posts in place. The last part to model was the Knurl Ring for the center disc. I started by offsetting the outside perimeter of the center disc so that the ring would sit just outside the diameter of the caps. I took a similar approach to what I did with the cap geometry, first creating a profile sketch and then revolving it around the center of the disc. The ring has a very slight indentation in the middle for the center disc to snap into. Like I did with any of the other repeating geometry, I modeled one knurl ridge and then patterned it around the ring. All of the pieces printed pretty well. I had some minor warping here and there on a couple of them, but nothing that caused issues with assembling them or them functioning properly. The only part that I had significant issues with printing was the outer knurl ring. The first version was so thin and had so many ridges that it just jostled itself straight off the print bed. After making some revisions to it so that it was a little bit thicker and had fewer ridges, as well as printing it with the brim, it came out perfectly. After assembling the first version, I ended up making a couple other functional revisions, mostly tightening up the tolerances and bringing the layers closer together. But most of my revisions were for feel or aesthetic. I increased the diameter of the indentation on the cap so that it fit my fingers better, and I made the outer ring taller so that it covered the edges of the caps completely. I also found that it was much easier to assemble the caps and the center disc and the posts first and then add the outer ring after you get the caps locked into place with the post, rather than putting the outer ring on first. I'm really happy with how the Fidget dial turned out. The final version has 12 magnet slots around both the center disc as well as the caps. Using different arrangements of magnets in both the center disc and the caps produces different indexing detents and different amounts of tension on the rotation. There are two different configurations that I've found that I like best. Both of them have magnets in all 12 of the slots in both the top and bottom caps. One configuration has 6 magnets spaced evenly around the center disc, and the other one has 3 magnets spaced evenly around the center disc. With 6 magnets in the center disc, the indexing is much snappier and requires a good amount of force to get it to free spin at all. With the 3 magnets on the other hand, the indexing is much less snappy, but it's much easier to get it to free spin. The one with 6 magnets will roll if you press it against a soft surface, since it can grip it better, but it has a hard time overcoming the magnet resistance on a smooth surface with less grip. The one with only 3 magnets has little enough resistance that it will roll easily pretty much on any surface. As a fidget toy, I think I like the 6 magnet arrangement more, but the one with 3 magnets works much better as a spinner, which will end up being important in our next episode because I plan to make new versions of this dial into spinner style dice. So stay tuned and make sure you're subscribed if you want to see that. I hope you'll try printing the Fidget dial out for yourself and let me know what you think down in the comments. I've uploaded a real-time assembly video with more tips on how to get it together and spinning well so that you can follow along with me putting it together. If you want to see the full unedited real-time process for designing this model, including me having to model complex parts of it twice because I accidentally made them upside down the first time, I've uploaded that under design sessions. A link to that video is in the description as well. If you liked the video, then like the video. If you didn't like the video, then dislike the video. Either way, tell me what you think down in the comments. If you want to see more videos about random stuff, then subscribe. You know how YouTube works. Stay Moxious.